Hello, today we are looking at section 8.4, Binomial Expansion Theorem and Pascal's Triangle. Pascal's Triangle is named for the French mathematician and philosopher Blaise Pascal, 1623 to 1662. He's a really smart guy that helped us, he came up with some pattern recognition. He was looking at a triangle, and we're calling this triangle Pascal's Triangle in honor of him. And he started with what he called the n equals 0 row, and it contained only the number 1. So he got to looking further, exploring a little further, and he realized that the following rows also contain 1 for the first and last entry in the row. And then as he started looking at the numbers within the triangle, the other numbers in the row are formed by adding the two numbers immediately above the number. And that's how the triangle is built. We're going to build one here shortly. But when you look at the triangle, there are a lot of things that were noticed about the triangle. That the second the second diagonals are counting number. The third diagonals are triangular numbers. The horizontal sums are the powers of 2. Each line in the powers is the powers or exponents of 11. But the most famous thing he's known for is that the numbers in this triangle can also be used as a way to expand binomials of higher order, meaning, something like x plus y to the power of 10. Okay? So here is his triangle. I would expect that you can create this triangle, so it's not about memorization, it's about knowing how it goes. So basically, the top number of the pyramid is 0, and that's what he calls the n equals 0 row, because anything to the 0 power is 1. And then the next row, n equals 1, is a 1 on each side of the 1. There's no space in here for another number, so you're just finished. As you move down the triangle, row 2 would have a 1 and a 1, but how do you get the number that's in between? Well, you add these two numbers above it together, so 1 plus 1 is 2. So if I move to the next row, I put a 1 on each side, and then to get this number right here, I would say 1 plus 2 is 3, 2 plus 1 is 3. So there's a little bit of symmetry there as well. So to get the next row, I put a 1 on each side, and then I would say 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. And I keep this pattern up as I work through the triangle. So for the n equals 5 row, I have a 1 on each end, here and here, and then 4 plus 1 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and so we have another row. If we do the 6th row, we put a 1 on each side, and then 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6. And we'll stop it in 7th row. So at the 7th row, we put a 1 on each end, just like before. Then we would do 6 plus 1 is 7, 6 plus 15 is 21, 15 plus 20 is 35, 20 plus 15 is 35, 15 plus 6 is 21, and 6 plus 1 is 7. And so you could keep that pattern going. Build more rows, but you should be able to generate this triangle based on what you know. A few words of caution: know that the top row here is n equals 0 row, not n equals 1, because anything to the 0 power gives us that 1 right here. If this were a power of 1, that would mean the binomial to power of 1, which is just going to have coefficients. Okay, so that's what that looks like. So some of these patterns that he noticed is like he looked down this diagonal right here, and those are counting numbers, 1, 2, 3, 4, 5, 6, 7. He looked down this diagonal right here and realized those were triangular numbers. When he looked across, the horizontal sums are powers of 2, and each line is the powers or exponents of 11. So there are lots of things that came out of it. We are going to use it for expansion. So as I'm looking at these values here, this is what I'm expanding, x plus y to the n. Well, x plus y to the 0 is 1, and anything to the 0 power is 1, so that's where that's coming from on the n equals 0 row. On the n equals 1 row, look at what happens here. It's just x and y. Well, what's the coefficient in front of x? 1. What's the coefficient in front of y? 1. Look at the next row, 1, 1. So if it's to the power 2, then I have two binomials. I'm going to FOIL them together. I get this trinomial, x squared plus 2xy plus y squared. Coefficient of x squared is 1. Coefficient of the middle term is 2. Coefficient of y squared is 1. 1, 2, 1. So you can see this pattern developing between the expansion and the triangle. So if I do this, I would take this result and multiply by one more binomial so that I get this trinomial who has coefficients of 1, 3, 3, 1. And we have 1, 3, 3, 1. So if I do the fourth one, I would take this long mess right here, and I would multiply by one more factor of x plus y, and it gives me this long mess, and the coefficients are 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. So you can see that pattern that's developing and a connection between the expansion and the actual coefficients of the triangle. So in combining these two observations together, he has developed a process to make the multiplication a lot easier. So his method says you expand the two terms of the binomial. The first term decreases, the second term increases. Then you use the appropriate row of Pascal's triangle to get the coefficients of the expansion. And then you simplify each term to get the expansion to its final answer. So that's the process we're going to follow, are those three things. So we went over this just a little bit a minute ago, but this would be my first term of the binomial. This would be considered my second term of the binomial. And so when we do that binomial to the power 0, well, it's just 1 because any number raised to the 0 power equals 1 except 0. Then we raise it to 1, it's just the x and the y. When we raised it to 2, we would FOIL it, so we get x squared plus 2xy plus y squared. When we wanted to go to 3, we take this trinomial times one more of these binomials, and so you would get this answer right here. And I would like to point out that all of you that keep trying to say x cubed plus y cubed are these three binomials. You can clearly see there's a big difference here, so don't fall into that trap. So then we would take this answer times one more x plus y, and then we would be down to our final, like, power of 4 if that's where we were going. So that's kind of the process we're working through. So if we were going to expand this with just our current knowledge, then we would take this binomial, we would write it down 4 times because that's what the power tells us to do. Then we would take the first two, multiply them together. Then we would take that answer with the next one and multiply it together. Then we would take that answer times the next one, and we would multiply it together and get your final answer. So that would be all of the steps that it would take to get there. So you can see that's kind of a lot because we've got all those powers, we've got all those x's, coefficients, all that fun stuff. Well, what it's going to look like today when we're finished is this. So from here to here is what Pascal's method looks like. And so it's a process of expanding the first term of the binomial by decreasing powers, expanding the second term in the binomial by increasing powers, putting in the numbers from Pascal's triangle, that's what you see here, 1, 4, 6, 4, 1, and then cleaning it up. Okay, so the first one that we're going to do is to expand x plus 2 to the 4th power, and we are going to use Pascal's method, okay? So the first thing I'm just going to write down, I want to write down what some of this information is, just to kind of keep us all going in the right spot. So in the first step, remember we said we were going to expand the first and second terms of the binomial. So in this case, the first term, it's just going to be x squared, is going to be decreasing, and the second term is 4, which is going to be increasing. So I start over here with my first term, which is x squared, and then the highest power of x is the power of the binomial, which is 3. But then I'm going to start with the second term, which is 4, but I'm going to start at the bottom end and start at 0. So this one is next in the next term as a decreasing power. This is in the next term as an increasing power. So then we are decreasing it one more time, and we are increasing one more time, and we are decreasing one final time, and increasing one final time. And so that's how we would take just step 1. In step 2, we're going to calculate the row needed from Pascal's triangle. The exponent of the binomial is 3 in our case, so the n equals 3 row is what's needed. And so we're going to multiply each term with a coefficient from the row in Pascal's triangle. So that n equals 3 row has the numbers 1, 3, 3, 1. And so remember that's coming back to here, 1, 3, 3, 1. All right, so once I know that, then I can actually do my expansion. So whenever I do this, I just put a little blank to put in my numbers, and then I do the powers behind it. So the first term was x squared, so I would say x squared, and I would start with a high power of 3. And then I would do my second term, which is 4, and power of 0. So then x squared decrease 1, 4, increase 1. X squared decrease 1, 4, increase. And then decrease 1 and increase. So then these numbers go in the blanks, 1, 3, 3, 1, and then you clean up each term. So when I simplify here, then that's 2 to the third power. So remember, when you multiply, raise a base to another power, or excuse me, raise an exponent to another power, you multiply. So that's going to be 1 times 1, because anything to the 0 power is 1, times x to the 6th, plus 4 to the first power is 4, times 3 is 12, x to the 2 times 2, plus 3, x squared, y squared, plus x squared 0 to the 0, so that's 1, and then you have 4 to the third power. Okay, so that's how you're breaking that down, and simplifying it should get us this answer right here. All right, so we're going to work through 3 more problems, and then we will be finished with our notes today. Notes today is just a bit short. So here's what we're expanding. Notice that the first term is now 2x. So you're not just saying x and decreasing it, but you're decreasing the whole quantity 2x. So you want to be sure you're writing parentheses around that. And then the increasing value is going to be 3. So the first thing that I'm going to do in the notes is just to make sure everybody's on the same page. So this is my first term, and remember, I'm putting parentheses around the whole thing. And then this is my second term. So the first term is going to be decreasing, the second term is going to be increasing. And then I want to know the binomial exponent. That's this part right here. That's a 3. So when that's a 3, then I know I need row n3 from Pascal's triangle, which is 1, 3, 3, 1. So the first thing we're going to do is get everything written down, and then we'll clean it up. So I have the first term, which is 2x. So I have 2x to the third, 2x to the second, 2x to the first, 2x to the 0. And then I'm going up. Y to the 0, y to the 1, y to the 2, y to the 3. And then I'm going to complete and look at these terms together, okay? So I know that 2x cubed is actually 8x cubed, because remember, this is a product in here, so it's 2 to the third, x to the third, and anything to the 0 power is 1. Then over here I have 4x squared. Over here I have a 1, and so then I put back together what's left. So it's 1 times 8x cubed. It's 4 times 3, which is 12y. 8x, sorry. And then you have nothing here has changed. And then here, anything to 0 power is 1, so that kind of cancels that out. So my final answer is this. Now this is what I'm breaking down. This is the final answer. You don't need to worry about rewriting it, changing the order. It's in the order based on whatever the first term was. And so we'll just leave it at that. Problem 3, we're going to expand 3 minus 2z to the 4th. A big note here, make sure if the second term is negative that you're sticking that negative to the number. So I'm not thinking about this as a subtraction problem where I have a positive 2z. I'm actually thinking that the negative 2z has a sign issue, right? So again, I'm going to list everything out I'm doing here. So I have 3 for my first term, which is here. Then I have this whole thing stuck together, so negative 2z, that's going to be my second term. The binomial exponent is 4 right there, and then it's going to be the 4th row, which is 1, 4, 6, 4, 1. It makes it a little easier to do the expansion. So for each term, I have my first term, which is 3, so 3 to the 4th, 3 to the 3rd, 3 to the 2nd, 3 to the 1st, 3 to the 0. And then my second term, which in this case is negative 2z, so I have negative 2z to the 0, negative 2z to the 1, negative 2z to the 2nd, negative 2z to the 3rd, negative 2z to the 4th. So you have to be careful of that negative, because like in this term where a negative is being raised to the power 3, that's negative 8z cubed. But over here, negative 2 square, or negative 2 to the 4th power is going to produce an even number, so you have to watch your signs there. So now we're going to clean it all up, and when we clean it all up, this is what we have. So 3 to the 4th is 81 times 1 times 1, and then 3 to the cube, 3 to the 3rd power is 27, 27 times 4 times negative 2. And so you just keep cleaning each term up that way. Don't forget, once you expand the terms, then don't forget to drop in the numbers from Pascal's triangle. So here's what we have. Our fourth and final example in our notes is 3 minus 2y to the fifth. So just like we've done in all the other problems, I'm hoping that as you see working through these first couple of preliminary steps, just kind of helps get your mind wrapped around the problem that you're working. So the first thing I would identify is my first term is 3. My second term is negative 2y. Remember, we're sticking all that together. The binomial power is 5, so I'm looking for the fifth row. And for the fifth row, that's 1, 5, 10, 10, 5, 1. So please take a moment. I don't expect you necessarily to write these things down, but it can be extremely beneficial in you getting everything where it's supposed to be correctly if you take a few moments to think about this before you start. So if you would like to pause your video for a minute and work this problem to see if you can do it without working through with me, I would suggest that, and then we will work it out, or I'll show you my work to this afterwards. Okay, let's see how you did. So as I was going through here, it's 3 to the fifth, 3 to the fourth, 3 to the third, 3 to the second, 3 to the first, 3 to the 0. The numbers from Pascal's triangle are 1, 5, 10, 10, 5, 1. Then the second term increases, and notice the parentheses around the negative 2y. So it's negative 2y to the 0, negative 2y to the first, negative 2y to the second, negative 2y to the third, negative 2y to the fourth, and finally negative 2y to the fifth. So it's very important when you're simplifying these things to keep in mind, because we do have a negative number down here that when we raise that to an odd power, we're going to get a negative answer. When we raise it to an even power, we're going to get an even number. So for instance, negative 2y to the first power is negative 2y. But over here, negative 2y to the second power would be negative 2 squared y squared, which is going to be 4y squared. Whereas over here, I have negative 2 to the third power, y to the third power. So negative 2 to the third power is going to be negative 8, because you can multiply 3 negatives together. And then you would have y cubed. And again, with the positive, negative 2 to the fourth power is going to be positive 16y to the fourth, and negative 2 to the fifth is negative 32y to the fifth. Okay, and this is negative because this was a negative number raising it to an odd power. So once you cleaned it up, how did you do? Did you get the answer? This is just, remember the problem, so this is what it looks like expanded. So some big numbers. Not all numbers will be this big. You should know a lot of these numbers, hopefully you recognize from that list that I gave you the very first day in this unit, patterns that you should be familiar with. I would strongly encourage you to make sure you know those lists, and that way that makes the expansion a little bit easier. So as you go to your daily practice in Canvas, 3 of the questions are self-graded questions, so you'll be able to put your answer in. Some questions might say, what's the coefficient? And in that case, you would tell me, like for this one, you might tell me 1080, right? And some of them may say, what's the term? And so you might need to give me all of this, like 240y to the fourth. So, you know, that's difference there. In addition to, you might just have to actually expand the whole thing. But 3 of those are self-graded questions, so I expect your score 3 out of 6. And then the last 3 questions are ones you're going to have to type in. So when you're typing in, you are going to go to the problem or the equation itself, and then there are 3 vertical dots on the paper. And on those 3 vertical dots, you can get to the equation editor. So what I'm talking about is once you're in the question, to find the equation editor, which is what you will need to use to get those questions in. So you're going to go to the question, and you'll see these 3 dots in a vertical box. You're going to click there, and it's going to drop down a menu, and it's going to give you an option that looks like that. This is a symbol for equation editor. So when you click that, then it's going to pop up a place where you can put subscripts and all of that stuff in very easily and be able to type in your polynomial. So I do have access to these 3 answers, so you're going to want to type them in so I can see that you did that. You don't have to type in your work, just type in your answer. and then check those 3 questions with me to make sure you got them correct. And that wraps it up. Next time we are going to be starting our review over this unit and kind of going back through. So this is our first real big unit that's totally pre-cal material. So please spend some time studying and preparing for your exam, working any extra questions you have, coming into tutorials, getting help, coming into advisory, getting help, or just coming in with your questions ready to ask me. And as time permits, we will definitely address those. Thanks so much, guys. Have a good evening.